Hey everybody, happy snow day. I just wanted to go over what we normally would be doing today if we were at school. So we're going to start with our do now. Typically we'd have a guided note sheet, but you're just going to have to stick with me and kind of get out a piece of notebook paper for this one. Work on the following problems while waiting for a math break. You guys don't have to have a math break because you're sitting at home. Find the slope for these three problems. We've got three problems, three different types of problems. These were all on your last quiz. So let's look at these really quick. We've got to find the slope from these 2 points. So if I'm looking at this one, remember our first step, and I've got a kind of weird pen I'm working with here, so bear with me. We've got 2 points, point 1 and point 2. We need to start by labeling them and figuring out which one's X and which one's Y. All right, next, remember we have our formula Y2 minus Y1 divided by x2, and again this is being kind of messed up for me, minus x1. All right, so that being said, we're going to take our y2. Y2 is going to be -3, so I'm going to have -3 minus y1, 19, divided by x2, -18 minus x1, which is our -18. So we've been practicing this for several weeks. Just a quick review problem so we can get our brains awake and thinking about math for a few minutes before you guys go back to bed. -3 minus 19. That's going to give us -22. Divided by -18 minus 18. Remember, if we're subtracting a negative, it's just going to cancel and we're just going to have a positive. So -18 plus 18 is actually just going to give us 0. So our slope is going to be -22 over 0. Now we talked about this in class. When we've got that bar right there, that represents division. So we can simplify that. Whenever we've got 0 on the bottom, you can't divide by 0. So if you typed in -22 divided by 0 in your calculator, you would get divide by 0 error. Whenever you get that, remember it's just undefined. And I'm just going to write that for now because my pen's being weird today. All right, next one. Find the slope from this one. Remember, we just find this by using rise over run. We're going to start at our leftmost point, and that's going to be between the 2 points. Find the one that's furthest to the left. We're going to have to go up. So we're going to find our vertical change over our horizontal change. We're going to go up 1, 2, 3, 4, 5, 6. So our vertical change is 6. And then we're going to walk over 1, 2. Horizontal change is 2. So our slope is 6 over 2. We can also simplify that. 6 divided by 2 is going to give us 3. So our slope is 3. All right, finally, we would just want to pull out the slope from this problem. Y equals -x plus 2. This one's not as hard as you might think it is. Remember, if we've got y equals mx plus b, that's the formula that we've been following. Remember, m right here represents our slope, b represents our y-intercept. So if it says find the slope, we just want to figure out that number that comes before the x. So in this case, we've got negative. Well, if we've got a -x, remember whenever you have x by itself like that, there's just an imaginary 1 in front of it. So our slope in this case is going to be -1. If they asked us for our y-intercept, then we would just pick +2. All right, so these are some frequently missed problems on our last quiz. I just wanted to make sure we went through these. Just a reminder, if you're not happy with your last quiz score on quiz 7, you can use, I'll give you guys some feedback sheets when I see you in person. But quiz 7 slope retake problems are on Google Classroom, and you can feel free to take those for some points back on your last quiz. All righty. Last time we saw each other, we talked about slope from 2 ordered pairs, rise over run, y equals mx plus b, slope types, and slope from tables. We have been talking about all sorts of different skills, so we're going to put those to the test today, but we're also going to look at something a little new and different. What's due this week? You guys obviously have your exact path 30 minutes due every single week. We're going to have an exit ticket that we, if we don't get snowed out, we'll do that in class. And You guys might have a quiz. I will let you know about that depending on when we can get in to see each other. But I just want to make sure that you guys all know what's kind of on your radar for a grade this week. All right, today's objectives. I can understand the difference between proportional and non-proportional relationships. I can identify a proportional graph versus a non-proportional graph. All right, so let's review. We talked about this in the fall, what a proportional relationship was. Remember, our K equals Y divided by X. A proportional relationship has that constant ratio of Y over X. That constant ratio is called the constant of proportionality. We've talked about that for several months. You guys all did a really great job with this part of our unit. And just to kind of review again, the proportional graphs have two properties. They're straight lines, which makes them linear. So they're constant relationships, making that rise over run the same. That rate of change is the same. It's constant. And it goes through the origin, so through 0, 0. And remember, we wrote them as y equals kx. So if I had a constant of proportionality of 20, then my formula or my equation would be y equals 20x. So we've had practice writing those a while back. So let's look at a non-proportional relationship. These are examples that do not cross the origin. Still same lines, but if you notice, both of these are not crossing at the origin. Again, the origin would be at 0, 0. These are crossing elsewhere on the y-axis. So we're going to look at these examples and talk about how to kind of figure those out. What's the difference in a real world situation. All right, so for proportional relationships, we write those equations as y equals kx. That's a review for you guys. Remember, they cross the origin at 0, 0. For a non-proportional relationship, this is where we're going to use that y equals mx plus b formula. So this is, and if those of you who are starting to understand the concept of a y-intercept, this is where that's going to come in. So these formulas, or I'm sorry, these equations do not cross the origin. All right, so let's use what we know about slope-intercept format. So let's look at this example really quick. What is the slope? So remember, y equals m, which is our slope, x plus b, which is our y-intercept. So if we're looking at this formula down here, what is the slope? Remember, slope is that number that comes before the x. So in y equals negative 9x plus 5, our slope is going to be negative 9. And then what is the y-intercept? That's going to be that number at the end, that constant at the end, the number that comes after the x. In this case, it's going to be positive 5. You guys also did a really great job with this. We're just kind of think about this in a different context today. All right, so let's use what we know again. So the slope of this one, y equals 1/3 x. Remember, if we're thinking about slope, slope is the number that's going to come before our x. So we've got a slope of 1/3. Our y-intercept is what? So if we're thinking about our y-intercept, it's the number that comes after the x. Well, in this case, there is no number that comes after the x. So there's just an imaginary plus 0 after that. So our y-intercept is going to be 0, meaning our line is going through the origin. So if we think about non-proportional versus proportional, this line is going to be proportional because it's going through 0, 0. All right, and remember, that's just written in that y equals kx formula that we've been talking about. All right, so let's practice these. Is this proportional or non-proportional? So remember, a non-proportional equation is going to have a y-intercept. A proportional equation is not going to have that y-intercept or that number after the x. So if this, I don't know if this note will help any of you, y equals mx plus b is going to be our non-proportional. Y equals kx is going to be proportional. So we've got our m, we've got our b, so this one's going to be non-proportional. Scroll down, y equals 5x. This one's going to, there's no y-intercept at the end, so there's an imaginary plus 0. So it's going through the origin, making that proportional. Same thing here. We've got our slope, but no y-intercept, so this one's going to be proportional. And finally, non-proportional or proportional. We've got a y-intercept. We've got that +3, that plus b at the end. So this one's going to be non-proportional. All right, so this shouldn't be too crazy, too different of what we've been talking about recently. Let's look at this graph. Is it proportional or non-proportional, and how do you know? So this is going to be something that's going to appear on a quiz in the future. So we're looking at this line. It's straight, so it's linear, creating a straight line. It's a constant relationship, and it's going through the origin. So if it's going through the origin, it's going to be proportional. How do we know? Because it goes through the origin. All right. Is this proportional or non-proportional? So this will also be something on a quiz where you have to look at a graph. Proportional or non-proportional? Well, for it to be proportional, it's got to go through 0, 0. And if it doesn't, it's going to start up here at 8. So that's going to make it a non-proportional relationship. And we know that because it does not go through the origin, or 0, 0. All right, so let's look at a couple things, and we're going to talk about some story problems. So constant terms versus variable terms. Well, back when we did our algebra unit in the fall, we talked about a variable term, which is a term with a variable attached to it. So 15x, 3x, negative 2x, negative 2t, negative 3s, something like that. A constant term is going to be any other number that does not have a variable attached to it. So it's constant. It's not changing. It's not being impacted by the variable. So again, constant terms do not change. They're constant. Variable terms can change because they're being impacted by the variable or the missing value. So let's look at an example. Oh gosh, I know you guys hate word problems. Miss Sprunger paid for meals for some friends. Each meal was $15. Man, I'm a good friend if I'm spending $15 on each friend. Each meal was $15. Write an equation that represents how much she would pay for any number of friends. So if I was going out to dinner and I didn't know how many people I was taking out, but I knew that it was $15 per meal. Well, let's go ahead and highlight or look at the information that we do now. So each meal was $15. So anytime you see each or per, that's going to represent some sort of multiplication. All right, so we're going to write our equation in either y equals kx or y equals mx plus b. Well, if I'm thinking of $15 per meal, this is going to be a proportional relationship because y equals 15x. If we think about this, if I had an x would represent my number of friends. So if I had 2 friends coming with me, then I could go ahead and plug in 2 for that x. So y equals 15 times 2. Well, 15 times 2 gives me 30. So that would mean for 2 friends, I would pay $30. And that's a constant relationship. It's not changing. Now let's look at the same problem, but it's a little bit different. Miss Sprunger paid for meals for some friends. Each meal was $15 and she left a $10 tip. Write an equation that represents how much she would pay for any number of friends. All right, the only way that this is different is we've got one extra number to think about. So we've got each meal was still $15 and she left a $10 tip. Any of you guys who know anything about tipping, this isn't a good practice. You definitely should be tipping based on the total of your meal, but we can talk about that at a different time. So I left a $10 tip regardless. So write an equation that represents how much she would pay for any number of friends. Well, if my choices are y equals kx or y equals mx plus b, well, remember when each meal was $15, my equation was y equals 15x. And it's like, that's our variable term right there, that 15x. When you leave a tip, that is a one-time payment. That is a constant number. That is not changing. That tip is not fluctuating. I'm giving them a $10 bill or a $10 tip and it's not changing. So that's going to be our constant in this situation. So our constant is going to be that $10 tip. So we've got y equals 15x plus 10. And this is going to represent how much money that I would spend for any number of friends. I'm spending $15 per meal plus that $10 tip that I left. And that y would represent how much money that I would be paying total. All right. The cost to rent a golf cart is $8 plus an additional $2 per mile. Write an equation for this situation. So we want to start getting in the habit of figuring out how we can write these equations, how we can think about this in a real world situation. So remember, our two options are y equals kx, which would be a proportional situation, or y equals mx plus b, which would be a non-proportional situation. All right, so let's highlight our important information. $8 plus an additional $2 per mile. So we're renting a golf cart. So let me read this one more time. The cost to rent a golf cart is $8. So we know that 8 is an important number, plus, we'll think about what operation that would be addition, plus an additional $2 per mile. Remember, whenever you see per, that's going to indicate multiplication. So the fact that I'm seeing two numbers here already tells me that I'm probably going to be writing a non-proportional situation. I just need to figure out which one's my constant and which one's my variable. All right, so let's go ahead and write this. So y equals, so I want to figure out what my slope would be. And in this case, you don't even have to think about it as slope. What is the rate in which I'm paying for something? Well, I'm paying $2 per mile. In this case, that mile is our x. So y equals 2x plus that original $8 that they charged me. So they said, okay, you have to pay $8 for this golf cart no matter how long you ride it. And then it's $2 for every mile after that. So our equation for that would be y equals 2x plus 8. All right. A pizza costs $10.50 for pizza plus a delivery fee of $5. Write an equation for the situation. All right, so we want to figure out, okay, what equation could we write that would represent how much we would pay given any number of pizzas that we bought? Okay, so again, just like the prior problem, I'm seeing two different numbers. I'm also seeing per pizza. So whenever you see that per or each, remember you're thinking multiplication. That's probably going to be your variable term. Okay, so we've got y equals $10.50 per pizza. So that's going to be my variable term, $10.50 for every pizza. And then we're paying that delivery fee, and that's a one-time fee. So that's going to remain our constant, a one-time fee of $5. So that would be an equation that we could write for that one. And once we see more examples, we'll get a little bit more familiar with it. All right. Easy Car rental charges $8.50 an hour plus a rental fee of $25.50. Which equation represents the total charges for X hours? So any amount of hours. All right, so we want to pick our options. We've only got 3 more problems, y'all. Stick with me. So if I'm looking at important numbers, they charge $8.50 an hour plus a rental fee of $25.50. So you need to be thinking to yourself, okay, I see 2 numbers. I need to figure out which one's my constant and which one's my variable. So $8.50 an hour, this means $8.50 per hour. So $8.50 per hour is going to be our variable term. Plus that one-time rental fee, that's not changing. We have to pay that $25.50 no matter what. So plus $25.50 is going to be our equation. And sorry, that's going to be y equals. So let's look at these. We've got 8.5 plus 25.5x. That's not right because that 25.50 isn't the number that's changing. We've got 25.50 or 25.5 plus 8.5x. Well, some of you guys might be looking at this and being like, oh, well, those are flip-flopped. But in this case, if it's flip-flopped in we're just doing addition, that's okay. And then in this last one, there is no X or variable term, so that one's incorrect. So for this one, we're gonna have B is our correct answer. All right, proportional or non-proportional. The video game rental fee is $15 plus $3 per day. What's the equation? Is it proportional or non-proportional? Well, we've got rental fee is $15. That's a one-time fee plus $3 per day. So for that, if we've got two numbers, it's going to be a non-proportional relationship. That's going to be y equals, we've got a rental fee of $15 plus that $3 per day. So 3 per day is going to be our variable term. So 3x plus 15. And remember, if we've got those two numbers that we're thinking about, it's going to be non-proportional because that's that y equals mx plus b format. All right, is the following equation a proportional or non-proportional relationship? Y equals 2x minus 1. Remember, y equals mx plus b is non-proportional. Sorry, it's supposed to be an n. And then y equals kx is going to be proportional. So we've got an m and we've got a b in this case. So that is going to be no, it is not proportional. All right, last one. Sanaa has $40 in her lunch account and pays $2 each day to eat lunch. Which equation can be used to find the amount? Whoops, that is a, find the, that's funny, that's not, how do we spell that? Used to find the amount of money she has left in her account after X days. So she's got $40 in her account to start with, and she pays $2 each day. So I'm gonna highlight this, $40 in her lunch account, and she pays $2 each day to eat lunch. So something, if you think about back to our algebra unit, when we're paying or we're spending money, if you're spending money each day on something, that money is leaving your bank account. It's leaving your account, it's going away. So in this case, we're gonna have $40, that's what we're starting out with. We're starting out with her $40 in her lunch account. We're paying, so we're spending money, so it's going to be subtraction, $2 each day. So we're looking for 40 minus 2x. Well, 2 plus 40x is not correct. 2 minus 40x, well, 40 isn't the number being impacted by a variable. 40 minus 2x, that looks good. And then 40 plus 2x. The reason it's not plus is because we're spending money. So the answer is going to be C in this case.